Now we have defined what a function is, and the key requirement of a function is if I have a function from a to b, every element in a has to be mapped to exactly one element in b. Now we are going to add some more restrictions in order to get some special types of functions. The first one is one-to-one function. As the name suggests, a function f from a to b is one-to-one if and only if distinct elements of the domain map to distinct images. So if other words, if I take two elements in A, they happen to be different, then they map to two different images. Another way of thinking about this is if I take any element in A, so two elements x and y, and their images happen to be same, this can only happen if the two elements I chose were equal. Observe that the function that I have shown over here is a one-to-one function. Essentially what I want is I don't want two arrows coming in over any of these elements. If I have two arrows coming in, that means that there's a problem. That's not going to be a one-to-one function. An onto function from a to b is, we call that function onto if and only if range and codomain are same. In other words, for all y in b, no matter which element I take from b, there exists some element in a such that f of that element is equal to y. In other words, no matter which element I take from b, I can always find at least one backward arrow going to set a. So this is an example. Here I have three elements in set b. If I observe each of these, there is something coming in here, there is something coming in here, there is something coming in here. That means this function is onto. A function is a bijection if and only if it's both one-to-one and onto. So here is an example. This function is one-to-one because I have exactly one arrow coming in each of these elements in B. I do not have a situation where some element has nothing coming in, and I do not have a situation where I have more than one arrow coming in into set B. So these two slides, I'm going to have some examples, and your job is to identify whether they're one-to-one function, onto function, bijection, etc. There is no audio on this slide, so it's just a blank thing for you to go through the slide one after another. You can pause as needed and see if you can identify what type of function it is, and once you have identified it, you can go to the next slide and you can see whether your answers are correct, and we will discuss more of this in class as needed. So this is example 1, 4 and 5. Okay, here are the slide with answers. See if your answer matches with what is on this slide. If it doesn't, this would be a good time to sort of go back, look at the definition, And if something is still not clear, it's a good idea to post a question on Piazza or identify a question to discuss in class with the group. Now that we have defined one-to-one functions, we can define a few other types of functions based on that. So let's say we have two sets A and B that are subsets of R, the real numbers. We say that a function from A to B is strictly increasing if the following condition is satisfied. The condition is for all x in A, for all y in A, if x is less than y, then f of x is less than f of y. In other words, f of 2 will be less than f of 3, f of 3 will be less than f of 3.1, and so on and so forth. A function f is strictly decreasing if we have exactly opposite, that is if x is less than y, that implies f of x is greater than f of y. Note that if I plot a function on a graph, this will be clear because in the first case I will see a function that keeps increasing forever. In the second case I will see a function that keeps decreasing forever. Note that a strictly increasing function has to be one-to-one because if I take two elements, they have to be ordered in some way because we are only dealing with real numbers, and that means if I take two numbers, f of x cannot be same as f of y. Inverse of a function is basically the thing obtained by reversing the arrows. So if I think of my function as those arrows from A to B, then I'm going to get the inverse of a function by reversing each arrow so that it goes from B to A. Note that this will only make sense if the function from A to B is a bijection, because otherwise what would happen is if I don't have any arrow coming into some element in B, when I reverse it, there won't be any outgoing element, there won't be any outgoing arrow from that element. If I had two arrows coming into an element in B, and then when I reverse it, I will have two outgoing arrows, and neither of this is allowed in a function. So if a function f is a bijection from A to B, the inverse of a function, still noted as f inverse, is a function from B to A such that this is a complex way of saying that you are going to reverse the arrows from B to A. So for all A in A, for all B in B, if f of A is equal to B, then f inverse of B is equal to A. If a function is a bijection, we say that it's invertible. That means the inverse function exists. Note that we can always change the arrows of the function f, but what we obtain may or may not be a function depending on what f is. If f is a bijection, when I reverse the arrows, it will still be a function, otherwise it will not be a function. So here is an example. Here f of A is 3, so f inverse of 3 is going to be A. And you can check the rest of the other elements as well. Let's look at some example of an inverse function. Here I have a function f from z to z, which is the set of integers, positive, negative, and 0 to z, and the function that we have is f of x is equal to x plus 1. F is a bijection. You can verify that f is a bijection and then ask the question, what is f inverse? Now the way we can find f inverse is So let's say f of x is equal to y. That means x plus 1 is equal to y. That means I can write now x in terms of y will be f of x will be y minus 1, and that will be f inverse of y. In other words, the inverse of f would be the function x minus 1. Another special kind of bijection we have is an identity function. An identity function is a function that maps a to a, and it maps each element in a to itself. Another special kind of function that I'm going to define is a characteristic function. A characteristic function maps the set A to the set 0, 1. So it maps some elements in A to 0, some elements in A to 1. A constant function is a function that maps every element in A to the exact same number every time. Once again, we have reached the check before you go ahead slide. I want you to identify which of these functions are one-to-one or onto. Remember, the functions look very similar to each other. All I'm changing is the domain or range, and that is going to change whether the function is going to be one-to-one or onto. The answers are at the bottom of the page, so check the answers, and if you have questions, please check with me or the TAs.